Student, today we are going to see two types of transformer working principle. Okay, there are two types of transformer. One is a step down, another one is a step up. Okay, step up will use for increasing the voltage, step down will use for the decreasing the voltage. If in case we had 10 it's 100 volt, okay, step down will be increased as the 10,000 volt. Okay, at the same time step down 100 volt is it will be decreased as a 10 volt. Okay, it is a step down, it is step up. Okay, see the construction. This coil we can take it as a primary, this coil we can take it as a secondary. Okay, in this step up case, primary will be thicker, secondary will be thinner. Okay, and primary number of turns is less, secondary number of turns is more. In a step down, okay, primary will be in a thin, secondary will be a thick. Secondary is thicker. Okay, so the reason where the voltage is less, there the in case here we are increasing the voltage, the current at the same time it will get decreased. When we are increasing the voltage, the current will be decreased. Okay, when we are decrease the voltage, the current is going to increase. Okay, we have to connect thick wire where the current is more. That means here it is a more current, here will be the more current. Okay, this all explanation we are going to see why it's a thicker, thinner, and why its a number of turns is a greater. Okay, so everything we are going to see. Okay, first we'll see what is ideal transformer. It is called primary coil, it is called secondary coil. Step up is representing the voltage is increased at secondary coil. Okay, step down is representing the voltage at decrease in secondary coil. Okay, so we are going to talk about voltage increase, current decrease in a secondary coil. In this case, voltage decrease, current increase in a secondary coil. Okay, now we are going to see what is ideal transformer. Ideal transformer. Ideal transformer, power input is equal to power output. So input power is equal to output power. Okay, so input power means the power is which one is in a primary coil, output power, the power we can take it in a secondary coil. Power is equal to voltage into current. It is in a primary, it is in a primary. Okay, so power output is a secondary coil, voltage in secondary, current in secondary. Okay, so now I want voltage in secondary, so primary we can bring it in a denominator, voltage in a primary. At the same time the current I am bringing as a here, so IP divided by IS. Okay, so this one only we are going to take it as a ratio formula. So ratio is equal to IP by IS is equal to VS by VP. Okay, so far we got only half of the ratio formula, we have to include with the number of turns also. Okay, this is a ratio formula. According to Faraday's law, E is equal to N times of d phi by dt. Otherwise, V, voltage is equal to. Okay, so voltage is equal to number of turns and changing flux. Okay, so voltage in primary we can take it as a N times of d phi by dt, number of turns in primary. Voltage in secondary, Ns d phi by dt. So we have the formula, ratio formula, voltage in secondary divided by voltage in primary. So ratio formula is equal to voltage in secondary divided by voltage in primary is equal to Ns d phi by dt is equal to Np d phi by dt. Why I am not changing flux? Because flux, whatever it's producing in a primary coil, the same flux we are going to transfer in a secondary coil. That is a maximum flux we are going to convert. We are going to assume the ideal transformer, there is no energy loss. Okay, so this get cancelled. So finally we got the ratio formula, R is equal to Vs divided by Vp, Ns divided by Np, and Ip divided by Is. Only I will be in a inversely proportional, other thing is will be secondary coil is in a directly proportional. Okay, now we will be seeing what is the difference between step up and step down. Okay, first it's step up, then step down. Okay, the ratio formula, if it's getting greater than 1, we can consider it is a step up because voltage is going to increase in a secondary coil. The ratio formula is less than 1, we can consider it's a step down. Okay, so step up when R is equal greater than 1. When R is greater than 1, that is the time voltage in secondary is greater than voltage in primary. And it's the same time number of turns secondary is greater than number of turns in primary. Okay, except current. Current is directly proportional. So current in a primary is greater than current in a secondary. Okay, it is for step up case when the R is greater than 1. The same time R is greater than 1 means Vs, Ns, Ip. This everything is numerator is greater, denominator is smaller. Okay, step down, R is less than 1. So Vs is less than Vp. Numerator is less than the denominator. So Ns is less than Np. Ip is less than Is. Okay, So this is a relation we got finally. Okay, step up is greater than 1, step down is less than 1. Okay, so voltage in secondary is greater than primary. That is a case we are taken as a step up. Okay, voltage in secondary is greater than voltage in secondary. Okay, so voltage in secondary is greater than voltage in primary. At the same time, the number of turns is greater in secondary coil. That is the reason I made here more number of turns. Okay, the current in a primary is more, so primary current is more. I should reduce the heat energy according to the Joule's law of heat energy. We can take it, it's I square RT. Because of I square RT, Joule's law of heating, the more heat will be produced in this side because current is more primary coil. Okay, that is the reason I made as a thicker wire. It will be reduce the resistance. Okay, and also it will be avoid the heat. Okay, the same next thing, R is less than 1, so voltage is secondary is less than primary. So voltage in secondary less than voltage in primary. Okay, we step down. Okay, so at the same time, the number of turns in secondary is less than number of turns in primary. Okay, so number of secondary will be less, so here will be less, here will be more. Okay, and the current in primary is less compared to the current in secondary. Okay, that is a reason secondary coil is a thicker coil, because it's going to produce as a overheat because of Joule's law of heating. Okay, thank you for watching my video. If you like my channel, please subscribe. Thank you everyone.